Now, you might want to watch these videos twice. Today is so important to what's going to happen with you guys with trigonometry for a while. You got to make sure that you know what you're talking about. Okay, so here's what I want you to do for here. I want you to go up to just one shy of being all the way up to the y and one shy of getting to the x. I'm going to try and draw a circle in the first quadrant there. There's a circle. Now I'm going to say there's this point xy that's on the circle. Okay, that's my point xy right there. For any point on the unit circle xy, I mean, I don't know if you noticed this or not. Look at the denominator every single time with sine and cosine here. So sine doesn't have to be opposite over hypotenuse in a unit circle. Sine can just be opposite. Cosine doesn't have to be adjacent over hypotenuse. It can just be adjacent. That's why we like using the unit circle, because the hypotenuse is 1 and it makes all of these easier to deal with. That's why we use a unit circle right there. Okay, and there's me drawing a terrible circle. Anyway, so for a point on the unit circle, created by rotating a terminal side theta degrees. Okay, so what I mean by that is there's my terminal side and there's theta. So there's, as from yesterday's notes, there's the initial side and there's the terminal side, and then I intercepted this unit circle with that point. Since the hypotenuse of the triangle will always be equal to the radius, r equals 1, this is the case every time. The cosine of theta is the adjacent over the hypotenuse. It's just going to be x. See, if I drop this down and create this right triangle, that side is x and this side is y. That's how you get to the point xy. So the cosine of theta will be x and the sine of theta will be y. Technically, it's x over 1 and it's y over 1, but you don't need it because you're on a unit circle. So xy on a unit circle is really cosine of theta, sine of theta. A point on the unit circle gives you two trigonometric values. Okay, so look, I'm going to just put in a whole bunch of stuff here. So let's try and draw a circle in the first quadrant right there. I'm going to call this the point 1, 0 for 0 degrees. I'm going to go at 30 and at 45 and at 60 and up here at 90. I'm not even going to draw the whole thing in there. But we learned that this is the point square root of 3 over 2, 1/2. Where did we learn that? Let's go back and look at it. That's for 30 degrees. Square root of 3 over 2x and 1/2 for y. Square root of 3 over 2 for x and 1/2 for y. Square root of 3 over 2 for x, 1/2 for y. For the 45-degree angle, we got square root of 2 over 2, square root of 2 over 2. Where did we get that? Again, back to this page. 45 degrees, square root of 2 over 2 is an x, square root of 2 over 2 is a y. This is the point, square root of 2 over 2, square root of 2 over 2. Maybe I should have said that on the last page. Okay, and then this last one is 1/2 and square root of 3 over 2 for the same reason as this. They got switched. See how they switched. And then at the top, this is the point 0, 1. Are you ready for this? This is where trigonometry gets easy if you're on board with this. The sine of 0 is the y value at 0 degrees. It's 0. The cosine of 0 is the x value at 0 degrees. It's 1. Don't believe me? Watch. Sine of 0 is 0. Cosine, where's it at? Cosine of 0 is 1. Tangent of 0, I'll get back to you on it. The sine of 30, so I'm going to go to where 30 degrees, I'm going to write it right in here. This was the 30-degree angle and the 45-degree angle and the 60-degree angle. Technically, that goes here, right? But just so you get the idea of where it is on the circle. The sine of 30 is the y value at the angle 30. It's 1/2. The cosine of 30 is the x value where the 30 degree is. It's square root of 3 over 2. Tangent, I'll get back to you. The sine of 45. The sine is the y value, so I go to 45, it's the square root of 2 over 2. The cosine of 45, it's the x value, so I go to where 45-degree angle is, I get the x value, square root of 2 over 2. The sine of 60, well, there's the point 60, it's going to be the y value square root of 3 over 2, and the cosine is this 1/2. And the sine of 90 is all the way up here, it's the y value 1, and the cosine of 90 is 0. All right, let's talk about tangent. I don't want to do too much here. I'm going to go up here, and I'm going to say tangent of theta from SOHCAHTOA is opposite over adjacent. right? It's opposite over adjacent. So if we look at this angle, it's y over x. And so according to this, tangent of theta is sine over cosine. Y over x. Opposite over adjacent. So if I have sine and cosine, I find tangent by going sine over cosine. 0 over 1 equals 0. Watch. The tangent of 0 is 0. Uh-oh. Fractions. That's all right. Watch this. 1/2 over the square root of 3 over 2. These 2's cancel. That's something you learned a long time ago. Or if you don't like that, you can flip the bottom and multiply. And the 2's cancel. You get 1 over the square root of 3, but you're not supposed to leave a square in the denominator, so you end up getting the square root of 3 over 3. Now, if you don't like that, I'm going to simplify that down here. Okay, watch. 1 over the square root of 3. You multiply the top and bottom by the square root of 3. That's a trick you learned in algebra. And so on the top you get the square root of 3, and the bottom you get the square root of 9, which is 3. Square root of 3 over 3. The tangent of 45, this one goes the sine, square root of 2 over 2, over the cosine, square root of 2 over 2. That's just equal to 1. The tangent goes the square root of 3 over 2, that's the sine value, over the cosine value 1/2, and the 2's cancel. So you get the square root of 3 over 1, which is just the square root of 3. And then this last one, tangent of 90, well, look at this. That's opposite over adjacent, but we've decided that's y over x. It's sine over cosine. You can't have a 0 in the denominator. This is undefined. There is no tangent of 90 degrees. There's a tangent of 45 degrees. Tangent of 45 is 1. But there is no tangent of 90 degrees. Watch. Tangent 90. The calculator blows up. All right, go to the next page.